Welcome to STEM Talk.
STEM Talk. STEM Talk. STEM Talk. STEM Talk.
Welcome to STEM Talk, where we introduce you to fascinating people who passionately inhabit the scientific and technical frontiers of our society.
Hello, folks. This is Dr. Ken Ford, IHMC's director and chairman of the Double Secret Selection Committee, which selects all of the guests who appear on STEM Talk. My wonderful co-host, Dawn Kernagis, is taking some time off and won't be with us today for our interview. My guest for this episode is Dr. Greg Potter, a British researcher who specializes in circadian biology, sleep, diet, and metabolism. Greg gained attention in the United States and Europe for his research on the importance of biological rhythms and sleep, and how they both affect people's lives. His work has been featured in the BBC World Service, The Washington Post, Reuters, as well as other scientific and news outlets. Today, Greg is a science writer, speaker, sleep coach, and consultant. He is also an entrepreneur who in 2020 co-founded Resilient Nutrition, a company that leverages science to produce food and supplements aimed at helping people feel and perform better. Greg received his undergraduate and master's degrees in exercise science from Loughborough University in England, before he headed off to the University of Leeds to research the influences and mechanisms of circadian rhythm. While working on his Ph.D., Greg became content director for humanos.me, a health tracking and support website that uses peer-reviewed courses and content to help people lead healthier lifestyles. Our good friend and colleague, Dr. Tommy Wood, who has been a frequent guest on STEM Talk and who contributed some of the questions for today's interview, describes Greg as, and I quote, one of those rare scientists who is able to combine real research skills and experience with an ability to distill information into a format that is easily understandable and actionable. He has particular expertise in the causes and solutions for sleep and circadian rhythm disruption, but is also exceptionally knowledgeable in how lifestyle in general affects health and performance. My conversation with Greg stretched on for more than 2 hours, so we have split Greg's interview into 2 parts. In today's episode, I talked to Greg about his youth and academic background and how he became interested in circadian biology. We discuss how he decided to specialize in sleep, and we also discussed his research into the role and importance of melatonin, a hormone that helps control the body's sleep cycle. In part 2 of my interview with Greg, we discuss therapies for insomnia, including sleep devices. We also cover sleep apnea and the role that diet and body weight play in sleep, which leads to a fascinating discussion about some of Greg's other research interests, including time-restricted eating, exercise, and nutrition. Before I get to my interview with Greg, however, I have some housekeeping to do. As regular listeners of STEM Talk already know, our Double Secret Selection Committee continually and carefully reviews iTunes, Google, Stitcher, and other podcast apps for the wittiest and most lavishly praise-filled 5-star reviews to read on STEM Talk. If you hear your review read on STEM Talk, just contact us at stemtalk@ihmc.us. to claim your official STEM Talk t-shirt. Today, our winning review was posted by someone who goes by the moniker Ted VA. The review is titled Renewed Love of Science. The review reads, "My love of science started in high school when I dated the chemistry and physics teacher's daughter. My love of science has been renewed by the very high quality of creditable, current, interesting science-related topics on STEM Talk." Well, thank you, Ted VA, and thank you to all our other STEM Talk listeners who have helped STEM Talk become such a great success. And now on to our interview with Dr. Greg Potter.
STEM Talk. STEM Talk. STEM Talk. STEM Talk.
Hello, this is Ken Ford, and I'm here with Greg Potter, Hello, Greg.
Good morning, Ken.
Glad to have you here. I understand that you had a great childhood growing up in Berkshire and Yorkshire. It is also my understanding that you had a lot of curiosity, as kids sometimes do. You loved rocks and the outdoors and rugby, but especially you seemed to love building things. In fact, you loved building things so much that you told an uncle that you wanted to be an engineer. Are my sources accurate? Does this all sound true?
It is true. Yeah, I had various obsessions in series, everything from rocks and minerals to yo-yos to sport, and some were related to building things. So specifically, I was very into Lego Technic and Meccano, and I can recall sitting on the floor working on a car when my uncle was visiting and him asking what I wanted to be when I was older. And I told him that I wanted to be an engineer, and he burst out laughing. And looking back, I probably exposed myself to quite a lot of nasty chemicals through the Airfix glue, and I think that might explain some of my moments of stupidity nowadays.
Was it the sort of very odoriferous glue that comes in a tube? It's sort of like a clear glue for making model airplanes and model cars and things.
Exactly, and it's impossible to get off your hands afterwards.
Yes, I know this stuff well. You have two older brothers and an older sister, and both of your parents are, in fact, teachers. So growing up, you and your siblings, I understand, actually lived on the grounds of the school where your parents taught. What was that like? That had to be an interesting experience, living on the grounds.
It was great. It was like having an enormous garden, and we were free to roam. We'd spend hours playing cricket and golf and passing and kicking rugby balls. And I think the groundsmen didn't really appreciate some of our wayward golf shots or the divots that we hacked out of their fields. But it was good fun. And interestingly, both of my parents taught me. My dad taught me geography and my mother taught me art. And so to this day, we still call them Mr. and Mrs. P.
That had to be an interesting experience. I grew up on partly on military bases, in Guantanamo and other places when my dad was in the Navy. And to me, as a kid, they were like giant playgrounds. I know the adults saw it differently, but it was great for me. And I'm sure growing up on the grounds of the school was a wonderful experience.
Absolutely.
So with both of your parents as teachers and you attended classes, as you mentioned there, it probably makes sense that you were very incentivized to get good grades. But at a certain point in your adolescence, you abandoned this idea of becoming an engineer and applied for an art scholarship to senior school. Is that right? And what precipitated abandoning the notion of being an engineer?
I don't know what precipitated abandoning the idea. I don't know if it was just my uncle. I suspect it wasn't. I'd probably moved on to different things by then. But yes, I applied for an art scholarship and an academic one too. I didn't get the art one, but I did love fine art. And I think a lot of that was due to my mum. And I think the downside was also that all that close work when I was young probably contributed to me being impressively short-sighted nowadays.
I can imagine that could be the case. What kind of art did you favor?
Just a lot of drawing and a little bit of paintings too, but I, for whatever reason, wanted to recapitulate things exactly as they were. So there was no creativity whatsoever looking back.
Yeah, I was remarkably untalented in art and drew nothing but flying saucers with bristling typically with guns or various weapons. And of course, in space, most of these weapons would have been useless, but I didn't know that. I just thought flying saucers were very cool and spaceships of various kinds. I was really awful at art.
Well, it makes sense that you ended up at NASA.
Yeah, maybe. I hadn't thought of that. So initially, as a youth, as you mentioned, you weren't all that enamored with science. But then you injured your back, as I understand it, playing rugby, and I can see how that would happen. And you were young, like 12 years old, and that led you to have more of an interest in science. Can you talk about how that injury sort of set the stage for your future studies and your interest in science and your career?
Sure. Yeah, I hurt my back in a scrum and saw a local physio. He gave me some exercises that didn't really help. And I then had back pain on and off for much of my adolescence, and tried to work out a solution, but didn't find a good one for a long time. And that coincided with me becoming more self-conscious and keen to look more attractive to the fairer sex. So when I started senior school, I began going to the gym and learning more about nutrition. And then throughout my teens, I spent much of my free time reading about exercise and food. And over time, the quality of my reading material got better. And near the end of school, I read Low Back Disorders by Stu McGill, which was very helpful. Yeah, I know you had him on the podcast, which was terrific.
Yeah, he's fabulous. And whenever I have a back problem, he's the person I turn to, actually. He's a very helpful guy.
He's the best.
So after graduating from high school, you were due to study English, as I understand it, at university, but took a year off. Why the year off, and what did you do?
I applied to study English in large part because I enjoyed it at school and it came quite easily to me. But then around the time that I left school to take a year out, I realised that studying English didn't make much sense given how I spent my free time and what I wanted to do later. So I reapplied to uni to study sport and exercise science at Loughborough, which is where I ended up.
Yes, in fact, your first exposure to real research, I think, came in a Physiological Society studentship that you had with Dr. Jonathan Folland. That was, I think, during your second year at Loughborough. That obviously made an impression on you, and he's a well-known person. Could you talk a little bit about that?
Yeah, of course. Looking back, I was lucky that I was a nerd. I was that guy that hung around after lectures to ask questions that came to me, and I got on well with some lecturers, one of whom was Richard Ferguson. So in my second year, the Physiological Society let Jonathan Folland get a student in to help out over the summer, and Richard suggested that he ask me. So I then spent much of the summer helping with a few different projects. One was working with Sarah Allison on some work looking at musculoskeletal morphological adaptations to hopping exercise in elderly adults. I spent a bit of time in the lab with Adam Fry, and he was looking at roles of the central nervous system in explosive strength training using electrical muscle stimulation. Mm-hmm. And then I also started learning how to use STS page electrophoresis to determine the muscle fiber composition of different muscles. And that was to look at the association between the composition of those muscles and sprinting and jumping performance in young men. And I enjoyed the summer. I got to see what academic life is like outside of university semesters. The internship also led to my undergrad project, which continued that work on muscle fibre composition. And ultimately my master's too, which then looked at whether ischemic preconditioning affected responses to blood flow resistant strength training. Blood flow restricted strength training.
All interesting topics, and mostly topics we've touched on in earlier interviews. Mm-hmm. I think all quite interesting. As an undergrad, you began coaching sprinters as well, and doing some personal training and some sports massage therapy. Can you tell us about that experience and what was, that you were pretty young and still early in your education. What was that like?
It was great. I'd always been interested in both science and practice. And so as soon as I started at Loughborough, I wanted to learn from great coaches. And the quality of their athletics coaches was notoriously high. So I contacted a couple of coaches, asked if I could attend some of their sessions just to watch them and learn something about their methods. And then partway into my first year, I was asked by somebody at HIPAC, which is the athletic centre, if I'd be interested in coaching my own group of sprinters by myself. And so for the rest of my undergrad and my master's, I coached a group of 18 to 25-year-old sprinters.
That had to be an interesting experience. And I always like sprinters because after their event, they typically look happy. They smile, they walk around happily. And I look at the endurance athletes, and at the end of their event, they suffer and they look unhappy and skinny.
They are a different breed.
Both are wonderful, I know. I always like the happy look at the end of the sprints. Well, you must have been a pretty good coach because in addition to the sprinters, you also helped two gentlemen break the Atlantic rowing world record, as I hear it. So this was two folks in one boat. Tell us about that.
Yeah, I hope this doesn't come across as false modesty, but I honestly wouldn't describe myself as being particularly good at anything. But yeah, the way that came about was through some work that I did to help my good friend Ali MacDonald. In 2019, he met Max Thorpe at an event that was about resilience, and Max had attempted to row the Atlantic with his friend Chris Williams in the 2017 Talisker Whiskey Atlantic Challenge, which is an event that goes on each year in which people try to row the Atlantic. And about 10 days into that 2017 row, in the middle of a huge storm, their boat got hit by a rogue wave. They capsized, and that sparked a fire on their boat too. They barely survived. And if anyone's interested, they should watch the TEDx talk the two guys did. It's called Fire and Water. Anyway, Max is a force of nature, and he returned to compete in the 2019 event, this time with his friend Dave Spellman. And after hearing Max's story, my friend Ali sponsored the pair and called me in to help out with their nutrition and their sleep during the row. And to cut to the chase, Ali and I take zero credit for this, but Max and Dave did really well. They went on, they broke the world record, and they crossed the Atlantic in less than 38 days.
Amazing. And that whole story is amazing, especially the rogue wave and capsizing. That had to be quite the event.
Yeah, true resilience.
For sure. When you finished your undergraduate degree at Loughborough, that was roughly coinciding with the 2012 London Olympics. And the Great Britain Olympic team used Loughborough as its base. That must have been a great place to be for someone who had just graduated with a degree in exercise science and who also had an interest in elite athletic performance. It had to be sort of hug heaven for you.
It was. There were lots of world-class athletes and coaches around throughout my undergrad, and I learned a lot just watching them in training competition. And I also feel very fortunate in that I spent a lot of time with great scientists and coaches, and I'm really grateful to them for that.
So you continued at Loughborough for your master's degree, but between your undergraduate and this graduate degree, you took a year off to do an internship in the sports science and sports medicine department of the Rugby Football Union. What was that like, and what was the work like?
That was very enjoyable and insightful, and I was fortunate to meet Dr. Simon Kemp, who oversaw my internship through my auntie. And I think I turned up to our first meeting wearing a scruffy jumper, and luckily Simon saw past that. We got on really well, and he asked me in to help him out for a few months. He took me under his wing. He was really good to me, and I helped out with lots of different projects, everything from injury surveillance to concussion assessment. I helped the Sevens players a bit with their nutrition, and I also did a little bit of work on talent identification.
So while you were still at Loughborough, you started to pay more and more attention to the role that biological rhythms and sleep play in people's lives. You decided to pursue a Ph.D. and ended up at the University of Leeds, where your research spanned circadian rhythms, sleep, nutrition, and metabolism. How did your interest in circadian rhythms and sleep evolve, and what led you specifically to Leeds? Why Leeds, given those are your interests?
My interest emerged from a few factors. One was just reading more about biological rhythms and sleep. And during my undergrad, I recall reading books by people such as the late Bill Dement. I also read a few really interesting papers. One was Frank Shear's 2009 PNAS paper, which looked at the metabolic effects of circadian misalignment. And I also, for whatever reason, remember reading an old review article by Jerry Siegel on sleep in mammals. Some of my interest also came from podcasts. There weren't many podcasts back then, but I started listening to them shortly before I finished school in 2008. And given that I was interested in ancestral health, I later heard people such as Dan Pardy speak about circadian biology and sleep on various podcasts. I'd also always wanted a rounded knowledge of health and performance, and it was very clear to me that circadian rhythms and sleep strongly affect those outcomes. And then finally, my own sleep had always been a bit unusual. I've always woken up hours before other people my age, and I'm frankly a strangely early bird. And I'd also had a few interesting experiences during sleep, nothing unusual, just quite frequent lucid dreams and a couple of bouts of sleep paralysis after I worked shifts at a bar at university. And so at this time I started scanning for PhD opportunities and found one on findaphd.com at the University of Leeds with Laura Hardy and Janet Cade and Peter Grant. And I really enjoyed meeting them. Didn't know Leeds, but I'd only heard good things, so I was quick to accept their offer to do my PhD there.
Oh, that sounds wonderful. For many folks, when they think of Leeds, they think of the famous live album of The Who, Who Live at Leeds. Are you familiar with that?
Before my time, Ken.
Yeah, it was one of the greatest live albums of its era. So over the years, you've become best known, perhaps, for your work on sleep. But I know you're fascinated by circadian biology and the effects that circadian rhythms have and the disruption of our circadian rhythm, the negative effects it can have on us. Related to this, you published a paper in Endocrine Reviews in 2016 on circadian rhythm and sleep disruption. Circadian rhythms are generated by what we call biological clocks. So, what is the body's biological clock, and why is it such a big deal if we end up with disrupted circadian rhythms?
I'm keen to set the stage, so is it okay if I give a long answer, Ken?
Absolutely.
Okay. So I typically frame my answer to this type of question in the context of evolution. And organisms evolved in the presence of relatively predictable changes in the environment, light, temperature, food availability. And we can think of these as a kind of environmental clock. And to thrive in these changing cyclic environments, organisms evolved their own timekeeping mechanisms or biological clocks. And these clocks produce biological rhythms, which are predictable changes in biology and hence behavior across different timescales. So we have very short rhythms, such as the heartbeat, and these are named ultradian rhythms. We have circadian rhythms. These recur every 20 to 30 hours or so, and there are lots of these: core body temperature, sleep-wake cycle, and so on. And then there are also infradian rhythms, which are the slowest rhythms. An example of these would be the menstrual cycle. And true circadian rhythms have a few different characteristics. So one, for example, is that they persist when somebody doesn't have any time cues. And this was first shown in humans in a cave in an experiment by Nathaniel Kleitman and Bruce Richardson. They're also entrainable. And what that means is that these rhythms aren't precisely 24 hours. So if you go and live in a cave without knowledge of time cues, you'll find that your clock typically ticks at slightly more than 24 hours on average. Some people will be faster than that, some slower. But as a result of this, we have to reset our clocks each day. And this is done by so-called time cues or Zeitgebers. And the most important of these in humans is light exposure. And then these rhythms are also temperature compensated. And what that means is that if you change the environmental temperature, it doesn't meaningfully affect the pace of these rhythms. And that's unlike processes such as photosynthesis, many other processes in biology. If you raise the temperature a bit, you'll speed up the reactions. And so anyway, the purpose of these clocks and rhythms is to optimize our bodies for specific behaviors and processes at certain times of day. And because we're daytime active or diurnal, we're basically optimized for activity and food intake during the daylight and then sleeping and fasting at night. And these clocks also help us anticipate and adapt to changes in the environment. So as an example of anticipation, each morning around the time that we wake up, there is the so-called cortisol awakening response, a sharp spike in cortisol synthesis. And the purpose of that is to increase arousal, mobilize energy reserves, raise blood pressure, readying us for activity. But we can also adapt to changes in the environment. And when you think about it, not all of your cells are directly exposed to the external environment. So we need internal time cues too. A really important one of these is melatonin synthesis, which occurs during darkness and therefore signals the biological nighttime. And some organisms are quite seasonal, and these seasonal changes reflect changes in the melatonin rhythm that's going on inside them. Interestingly, it's likely that every single cell in your body has its own cell-autonomous molecular clock. But with that said, a helpful way of thinking about your clockwork is dividing it into a master clock or central clock in the brain, and then all of the clocks outside of the central clock, which we often refer to as peripheral clocks. And a common analogy is that your circadian clocks are a bit like an orchestra in which the central clock is the conductor. So while there are lots of individual instruments, the peripheral clocks, which might be playing perfect melodies, if they're not in time, in circadian terms, that would be if they're out of phase, or if they're playing at the wrong speed, so running at the wrong period in circadian terms, or if they're playing too quietly or too loudly, which would be referring to the amplitude of those rhythms, then the sound of the whole orchestra suffers, meaning that the circadian system doesn't function so well. With all of that said, the bases of these circadian rhythms come from the master clock primarily, and this is located in the front of the hypothalamus. and it's named the suprachiasmatic nucleus. And it's named that way just because it sits above where the optic nerves cross. And this is probably most important to circadian regulation of biology and behavior. There have been lots of experiments in rats showing that if you lesion the SCN, the suprachiasmatic nucleus, then you basically get rid of circadian rhythms in things like sleep and wakefulness and some hormones and feeding behavior. And this master clock is set primarily by the patterns of light that your eyes are exposed to. That information is relayed directly back to this master clock, and then it sends that information onto the pineal gland that synthesizes melatonin. And melatonin then circulates throughout the body, acts on a couple of receptors, and tells cells that it's the biological nighttime. And the SCN also sends messages to peripheral clocks through a few other mechanisms. So one, for instance, is the regulation of body temperature. And then meanwhile, these peripheral clocks are somewhat set by signals from the SCN, but they're probably also in part set by patterns of food intake. This hasn't been very well demonstrated in humans, but that seems to likely be the case. So with all of that said, why is it a problem if we disrupt our clocks? The short answer is that most, if not all aspects of our biology suffer, and many of us have felt this during jet lag. And it's probably also worth mentioning that circadian rhythms tend to become less robust as we age, as does sleep. And obviously the effects of this type of disruption depends on the nature of it. Sometimes the disruption is due to some sort of biological dysfunction. So there are people who are blind who don't have functional retinal photoreceptors, and as a result, they can't synchronize their clocks properly with the light-dark cycle. But sometimes the disruption is environmental. And just as one example of this, maybe during shift work, the light-dark cycle is misaligned with the timing of the master clock in the brain. And one way that we can get at how this type of circadian misalignment affects us is through experiments in which you basically give people light-dark cycles that they can't synchronize to. So if you impose a 28-hour day in quotation marks, then the body's clock can't synchronize that 28-hour day, so it runs at its own pace. And after 3 of those 28-hour days, all of a sudden somebody is awake and eating at roughly 12 hours from when their bodies would expect to be awake and eating. And so you can start to understand how the circadian misalignment is affecting them. And a few researchers have done some great work on this, Frank Shearer in particular, and he's published many studies, but one of his early studies found that within just 3 days, 3 out of 8 previously healthy people were diagnosable as being pre-diabetic as a result of that type of circadian misalignment. And he's since shown that misalignment increases blood pressure, it increases inflammatory markers, it shifts the timing of many bodily rhythms. So it seems that circadian disruption underlies some of those consequences. And then it also reduces heart rate variability, so it has some cardiovascular consequences too. And importantly, some of these effects seem to accumulate over time. And it also seems that people don't really adapt to circadian misalignment. Frank's done some work on shift workers, showing that if you take healthy people who work shifts on a regular basis and you subject them to the same type of misalignment, the misalignment still negatively affects their blood sugar regulation and their insulin sensitivity. And it could also be that there are some small sex differences between people and how they respond to circadian misalignment. So there's just some instances of how this affects us.
That's a truly wonderful answer and very clear and well articulated. In that discussion, you mentioned our peripheral clocks, which exist outside of the master clock. Could you give us some examples of these peripheral clocks and explain some of the specific roles it's believed they play?
Yeah, of course. So I'll use a couple of examples. One is blood sugar regulation. And I mentioned Frank Shearer earlier. He published a nice study in 2015 showing that people's glucose tolerance is about 17% lower in the biological evening than it is in the biological morning. So give them a standardized meal and their blood sugar swings more if it's given during the evening than the morning. And since then, there's been a meta-analysis looking at all the relevant studies that have been done, showing that blood sugar responses and insulin responses are worse when people consume meals during the evening, so between something like 8 p.m. and 4 a.m., than earlier in the day. So why is this the case? Well, there are a few factors that are at play. One is that the peripheral clock in the gut regulates glucose absorption. So glucose uptake in the digestive tract is going to vary according to time of day. Another is that the clock in the pancreas regulates insulin secretion. And we might come to this later, but melatonin actually inhibits insulin secretion as well. And so for that reason, if you consume a meal during the biological nighttime when your brain is producing a substantial amount of melatonin, then you're probably not going to produce as much insulin in response to it, and hence your blood sugar is going to swing more. And then you also have peripheral clocks in your skeletal muscle, your fat cells, and your liver that affect local insulin sensitivity too over the course of the day. So all those factors contribute to that day-night difference that I mentioned earlier. And then as another example, if we look at cardiovascular function, then various cardiovascular events, heart attacks, sudden cardiac death, stroke, tend to cluster in the morning. And interestingly, this is relevant to surgery too. There's a guy at the University of Leeds, Bart Stiles, who did a really interesting study on this a few years ago, and he found that compared with afternoon surgery, when people got surgery in the morning, patients were much less likely to experience adverse events. And the surgery they were having was basically a surgery because they had aortic stenosis. So the aorta was narrowing. And of course, that can ultimately threaten their lives. So clearly, this has implications for when we treat people too. And some of the factors that underlie this increased susceptibility to problems in the morning probably include differences in things like platelet activation, endothelial cell nitric oxide, which affects how well your blood vessels dilate. Some different clotting factors might also be that because various catecholamines, so things like adrenaline, are higher in the morning, that contributes to increased risk at this time of day. And then the heart itself might also be more prone to arrhythmias early in the daytime too.
That's very interesting.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research lab pioneering groundbreaking technologies aimed at leveraging and extending human cognition, perception, locomotion, and resilience.
In the past, you've often spoke about how humans once lived essentially by what could be thought of as two clocks, one being an environmental clock and the other a biological clock. The natural biological clock of our ancestors was no doubt highly synchronized with the outside environmental clock. But we modern humans now seem to live by a third clock, which you've referred to as a social clock. Can you talk about that and explain why this third clock has such a profound impact on humans?
So we can think of the social clock as being synonymous with local time. And I'll just add that much of my thinking on this has been shaped by the work of Till Roneberg, who is a fantastic German chronobiologist. So just want to give him credit. But with that said, the social clock, I think, became more prominent as a result of industrialization. So if you think about the Industrial Revolution, then one of the developments that took place was artificial lighting, and a huge mass of the Earth is now affected by artificial light at night. And the area that's affected seems to be growing and intensifying over time too. The other problem is that we now spend something like 88% of our days indoors in industrialized societies. And obviously that's an average value. But to give you an idea of why this is the problem, indoor lighting is often much, much lower in light intensity than what you would experience outdoors. So in this room that I'm sat in right now, I'm probably exposed to something like 300 lux. Lux is just a unit of light intensity. It's the amount of light that's emitted by a candle held 1 meter from the eye. But if I go outdoors, then here in Bristol, it's overcast and wet, but the light intensity is probably something like 10,000 lux. So probably roughly 30 times more intense than what it is in this room right now. And then at the same time, of course, we've engineered physical activity out of our lives, and we've also uncoupled it from food acquisition. So whereas we once had to be active to get food, we don't nowadays. And in the US, I think something like 86% of people don't meet the physical activity guidelines set by the government. So those were some consequences of the Industrial Revolution. And then, of course, we've had the digital revolution too. And nowadays we can work in distributed teams across different time zones, and that can contribute to circadian disruption as a result of this social clock construct. Then there is daylight savings time, And what this does is it basically advances the social clock with minimal influence on the biological clock. And it clearly is a problem. So Saline Vetter published some work quite recently showing that the daylight saving time transition led to about a 6% rise in fatal traffic accidents in the US. And a lot of those seem to occur in the morning, which is no great surprise given their proximity to sleep. And interestingly, people in the west of a time zone are affected more than people in the east. And I'll come back to that in a minute. But with all of that said, we should just have standard time year round. And the time zone, of course, should be positioned in the center of each time zone. And then on the subject of time zones, our body's clocks still follow the sun, despite whatever the social clock does, whatever local time changes we enforce. And the Earth's rotation means that the sun moves from the east to the west. And that, of course, is true within a time zone too, which explains those findings that I mentioned earlier of Saline Vetter. And Till Roneberg, who I mentioned earlier, has done some nice work showing that mid-sleep time is later in people living in the west of Germany than people living in the east. So within that time zone, it's clear that the actual sun clock is still affecting people to some degree. And if we think about other countries, then sometimes there's a huge discrepancy between the time that's enforced and the environmental clock around us. So Galicia in northwestern Spain, for instance, is about an hour and a half out of sync with the sun. And in China, they use a single time zone, despite its size. So it should probably span 4 or 5 time zones, but they use just one. And then, of course, the social clock also includes things like shift work. And what I would emphasize is that the problem here is the rate of change. Evolution, I think, can be relatively rapid, but humans are long-lived, and we existed as pre-industrial people living hunter-gatherer lifestyles for more than 90% of our time on the planet. So we're not well adapted to these changes, and that probably explains why we cope so poorly with circadian disruption nowadays.
You mentioned shift work, and this seems to be a prime example of the consequences we face when we live against our biological clocks. Sachin Panda, who was our guest on episode 29, has done some research on this as well. I know you published a review article on shift work with Tommy Wood a couple years ago. What do we know about how shift work affects people, and could you tell us about the findings in your article?
Of course. The article is just a summary of relevant research. Tommy asked me to help him out with that, which I am very grateful to him for. Tommy is a great man, so shout out to him. But with that said, shift workers are at greater risk of accidents than the rest of us. They probably have something like 50 to 100% higher risk of various types of accidents than non-shift workers. And this risk is exacerbated by doing long shifts, such that people who work 12-hour shifts probably have about twice as high risk of accidents as people doing 8-hour shifts. They're also disposed to developing lots of different diseases. I don't want to sound morbid in saying this, but based on systematic reviews, if you compare them to non-shift workers, they probably have something like 25% higher risk of type 2 diabetes, about this same increase in risk of coronary heart disease, a slightly increased risk of stroke. They're probably predisposed to weight gain and certain cancers and mood disorders too. And interestingly, there was a recent analysis of the UK Biobank dataset which found that shift workers are much more likely to have asthma too, so maybe it's affecting their respiratory function. And perhaps especially concerningly, there's been some recent work by Claudia Moreno suggesting that night shift work might actually have some intergenerational effects. So if you compare pregnant night workers to their pregnant day working counterparts, the night workers have lower nighttime melatonin production. They are more likely to need some sort of assisted delivery at birth, so C-section, for instance. And their newborns also have lower scores in an index, which is basically a way of summarizing the health of newborns. And they're more likely to experience breastfeeding difficulty too. So with all of that said, it's of course hard to work out what the contribution of circadian disruption is to these problems, because shift work also affects relationships and sleep and so on. And on the subject of sleep, I think sleep probably mediates some of these effects, because shift workers who work nights or very quickly rotating shifts probably get less sleep than many others. And they're probably more prone to certain sleep disorders too. About a quarter of shift workers experience shift work disorder, which is a problem which they struggle to adjust their body clocks to their shift schedules. And as a result, they're very sleepy during the daytime and they have high levels of fatigue during wakefulness. And then when they do try and sleep, they experience insomnia. So that's a long way of saying that shift work is problematic, but fortunately there are some things that we can do about it.
Well, you just mentioned there are some things we can do about it. And I realize that this is a field that's only recently, relatively recently, gained a lot of scientific interest and investigation. I was wondering if you might talk a little bit about what are some current best practices to optimize health and performance for those who really must do shift work. That's for many occupations, it sort of comes with the territory. What should these folks do?
So I'd actually start at the level of the organization and then think about the individual afterwards. And I'd emphasize not thinking about interventions as costs, but rather as ways to generate value. And with respect to the organisation, I think it's important to try and identify the employees who are at highest risk for shift work disorder, which I just mentioned. There are things that you can do to shift schedules to help workers too. Most workers tolerate quite quickly rotating, forward rotating, which means that rotation is clockwise schedules better than slower backward rotating schedules. And if you want to support worker well-being, then I don't think that any one shift should be longer than about 10 hours or so. They need enough recovery time between them too. And I think the total amount of work each week matters as well, of course. And typically guidelines will push for no more than about 60 hours of work per week. I think giving workers some autonomy over their schedules and ability to tailor their schedules by chronotype makes sense too. And with respect to chronotype, there's an interaction between chronotype and shift work schedule that affects disease risk. So as one example of this, breast cancer risk seems to be higher among morning types, like myself, who work night shifts. And so if we can personalize work schedules by removing the most strenuous shifts, which would mean night shifts for early chronotypes or morning shifts for late chronotypes, then we're likely to improve workers' sleep, improve their well-being too. And then I think we should also give these people spaces in which to nap if they need to and exercise, and ideally make it easier to make healthy choices. And there are lots of things that you can do with respect to the environment that can facilitate that. You can give people free fruit, for example. You can change the placement of food at the canteen. And then obviously there's an educational element that you need to consider too. You need to teach workers about these different factors. And then if we move on to the individual, there are a few different things that I think are especially critical to consider. So one is just light exposure. It's really hard to get light-dark cycles right at the level of the organisation because people are working different shifts and the optimal light-dark cycle is going to be different for each of us. So I think if you're a worker, then if you're struggling with fatigue during shifts, then you might want to keep some sort of high-intensity portable light handy, just in case you need a boost in your alertness and you want to sharpen your brain function. I think if you are back at your place after a hard shift and you're struggling to unwind, then using some sort of blue blocking glasses is unlikely to hurt. You can also use sunglasses while you're traveling home after shifts. The one thing to consider though is that could have some small effect on how drowsy you feel. And obviously you don't want to drive when you're feeling drowsy. And then there's exercise. Again, there's not that much work on the best way to exercise in this context, but there's some preliminary research showing that if, for instance, you have people do just 15 minutes of cycling exercise on a regular basis during shifts, then you might adjust your clock better to a change in your shift. And that exercise is also going to promote alertness and brain function and so on too. And then with respect to sleep, I think most of the usual sleep hygiene tips apply. And there are just a couple of things to consider. So one is that if you're sleeping during daylight hours, then it's especially important to address light in the bedroom and the temperature of the bedroom too, because you're more likely to have light coming in and the temperature might be higher than is ideal. I think in general, you want to try and anchor the timing of your sleep by creating a sleep period that overlaps with when you'd prefer to sleep on both work days and non-work days. I realise that that's not always feasible, but the more regular you can keep your sleep, the better. And then obviously you use napping judiciously too, because that can boost your brain function, increase your alertness, reduce fatigue and so on. It's not really clear what the best nap duration is. Probably depends on what is happening straight after the nap. But in general, I think naps containing about 20 minutes of actual sleep tend to work quite well. And then finally, with respect to nutrition, similar to sleep, if you can maintain a relatively regular meal pattern, then you're going to support your metabolic health. And I think if you're going to snack outside of that eating window, then you probably want to select snacks that are quite satiating, ideally quite easy to digest, and snacks that don't cause huge spikes in your blood sugar. So that might mean things such as cheese and eggs and nuts and fruit, vegetables. And you probably want to keep each of those individual snacks quite small, maybe no more than about 10% of your energy intake. And then finally, there's caffeine too. And I'll just mention caffeine because it can be critical to safety. And with respect to shift work, I think more frequent, lower doses of caffeine tend to work well. So rather than having a larger bolus of caffeine, you might want to consume something like 1 milligram of caffeine per kilo of body weight every hour or so for the first few hours of a shift if you're really struggling with your alertness. You won't notice it strongly in terms of a jolt in your alertness, but it will help maintain your performance through the shift when you're really struggling.
That all makes sense. And, shift work is part of our society. And in some professions, it's just going to be that way. Imagine law enforcement officers or a lot of the key roles in the military, partially enhanced by night vision goggles, occur at night. And I anticipate it will continue. So it's interesting to see what people and organizations might do to mitigate some of the negative effects. Some of the issues around shift work have to do with melatonin, a fascinating topic that you touched on in your Ph.D. research. Can you talk about the role and importance of melatonin? And then after that, would you talk a little bit about your views on melatonin supplementation?
Yeah, of course. And one way to think about melatonin's effects is by dividing those effects into effects that depend on melatonin receptors and then effects that don't depend on those receptors. So, for instance, I mentioned earlier that melatonin signals the biological nighttime throughout the body, and that's a receptor-dependent process. But melatonin also has lots of antioxidant and anti-inflammatory actions. It can influence mitochondrial function too. And I think coupled with the effects of melatonin on sleep, that partly explains interest in using melatonin as an adjunct in disorders such as COVID-19 and brain injuries. But melatonin can also affect things like reproductive function. I don't think the size of that effect in humans is particularly big, but interestingly, that there might be some applications, in particular because using melatonin on a regular basis might influence blood sugar control. It could be that it helps with conditions such as PCOS. And then I mentioned earlier that melatonin has some other metabolic roles too. And probably the best characterized of those are its effects on blood sugar control and insulin action. And so, as I mentioned, melatonin inhibits glucose-stimulated insulin secretion, but it does so more in some people than others. About a third of people around the world have a variant of the gene that encodes one of the melatonin receptors, and this variant associates with increased risk of type 2 diabetes. And that effect is probably mediated by a few things. One is that it might amplify how much melatonin reduces insulin secretion, which will lead to worse blood sugar control. And sure enough, people with this variant have a small but significant increase in risk of elevated fasting glucose, type 2 diabetes, and gestational diabetes too. So with that said, you asked about melatonin supplementation. I think there are a few instances in which it can make sense. One is to help sleep, of course. And I'll preface this by saying that a small number of people have had their pineal glands removed. The pineal gland synthesizes most of your body's melatonin, not all of it, but most of it. And these people have relatively normal sleep. So I'm not convinced that melatonin is essential for healthy sleep. But with that said, I think the strongest indications for using melatonin are certain circadian rhythm sleep-wake disorders, jet lag, shift work disorder that I mentioned earlier, delayed sleep phase syndrome, which is a disorder in which people go to bed and wake up very late, and then non-24-hour sleep-wake rhythm disorder, which I alluded to earlier when speaking about blind people and the fact that their clocks can't synchronize with the world around them, and so their clocks run free, meaning that it's almost like they're in a state of jet lag about half the time. And then melatonin might be somewhat helpful in insomnia too. So regular use tends to slightly shorten how long it takes to fall asleep, slightly improve sleep efficiency, the proportion of time in bed that you actually sleep, and slightly prolong sleep. And then I think melatonin can be helpful in something that's known as REM sleep behavior disorder, which is a problem in which people act out their dreams. And this particular disorder is very problematic. People who have a much higher risk of developing certain neurodegenerative disorders such as Alzheimer's and Parkinson's. And REM sleep behavior disorder is often treated with quite potent drugs. Melatonin has a much better safety profile. It doesn't have that many drug-drug interactions, and that's really important for elderly people who are often already taking lots of medications. And it also seems to slightly reduce muscle activity during sleep. So it can minimize some of those behaviors that I mentioned. And then perhaps melatonin could be helpful for some metabolic and inflammatory disorders too. There was a meta-analysis not long ago showing that melatonin supplementation can slightly reduce fasting insulin levels and perhaps slightly reduce insulin resistance too. A lot of people are interested in whether it could be helpful in COVID-19 now, because obviously it's in large part an inflammatory disease. And I think outside of disease, there are certain environments in which melatonin can be especially helpful. So if you're in a very brightly lit environment and all of that light is going to shut down your body's own synthesis of melatonin, think about staying in hospital, for instance, I think melatonin could come into its own at those times too. And then finally, I'll add that long-term use actually seems to be quite safe. And this is somewhat disputed. And a lot of people are concerned about using melatonin in kids. Understandably, they think that it might have some reproductive consequences. But there have been studies of children who have autism and insomnia in which they're given melatonin for 2 years at quite high doses. And they've just found that their sleep is a little bit better and their quality of life is slightly better too. There aren't any obvious effects on growth or development. So I'm not suggesting that people should use it in their kids. I'm just saying that the safety profile is impressively good. And then finally, the other thing to mention, which is really a fly in the ointment actually, is that if you're buying your melatonin over the counter, then it might not meet label claims. So if possible, if you want to use melatonin, I'd look to get it on prescription. And I mentioned this just because there was some work that came out not long ago which took melatonin supplements off the shelves, and they found that the actual melatonin content in the tested capsules ranged from about 80% less than what was on the label to about 480% more than what was on the label. And even within a particular product, there was quite large variation in the contents of melatonin. And then a small proportion of the supplements also contain serotonin. So there's a quality control issue at play too.
Yes, melatonin is an object of widespread interest, as you know, and Russell Ryder and others have done a lot of research on melatonin. You mentioned the quality of off-the-shelf melatonin, let's put it that way. Consumers Lab, I think, not too long ago looked at melatonin and found some, as you said, that were not dosed appropriately. The Consumer Lab is behind a paywall. You know, it's a pay site, but some people find it quite useful.
Yeah, it's a great website, and I have read that article actually, and I seem to recall that a Swanson product and a life extension product contained what they claimed to and were among their recommendations. One of the issues is just that factors such as dose do matter, and also the melatonin pharmacokinetics matter too. So, for example, there are instances in which timed release melatonin makes the most sense.
Yes, I was just going to ask you about that, if you could talk a little bit about that.
Yeah, of course. So if you have problems with sleep maintenance, you struggle to sleep through the night, then time release melatonin can make a lot of sense. And whereas the half-life of regular melatonin is typically a bit less than an hour, something like 45 minutes, the half-life of some of the different time-released formulations, such as Circadian, is closer to about 4 hours. And so the time-release melatonin better mimics your body's natural melatonin profile. And there have been a few studies, in particular of elderly people, showing that if they take this Circadian product, 2 milligrams, they sleep through the night better than they're able to if they take placebo. And then if you're using melatonin for its effects on your body's clock, say that you want to get over jet lag faster, then you want to use regular melatonin. You want that fast profile, and a lower dose is better in this instance because the higher dose will slow down the melatonin, and what that means is that the melatonin is more likely to spill over to the wrong part of what's called a phase response curve. The idea is just that if you take melatonin at different points in your circadian cycle, you can pull or push your body clock in different directions. So if, for instance, you took melatonin about 5 hours before you normally go to bed, you'll tend to drag your sleep earlier towards you. You'll be able to fall asleep earlier than you otherwise would be able to. And that can be helpful if you're going east, for instance. If you were flying west, then you want to push back your body's clock. And in that instance, if you took melatonin around the time that you wake up in the morning, you'll tend to achieve that. And just on the subject of jet lag, I have no affiliation with them whatsoever, but there's a website that I really like named jetlagRooster.com that will give you personalized recommendations about when you should expose yourself to light, when you should avoid light, whether melatonin makes sense in your context based on the specifics of your travel, where you're going from, where you're going to, whether you want to adapt in advance or not. So the different types of melatonin can be helpful for different purposes. Dose matters too. And just to add one more point to the latter, it might be that higher doses are better in some cardiometabolic health problems. And I mentioned PCOS earlier. Some of the work on PCOS has given people about 10 milligrams of melatonin. So whereas for jet lag, you might want to use between 300 micrograms and 1 milligram. For something like PCOS, you might want to use a substantially higher dose than that. So the devil's in the details as always.
You mentioned REM sleep disorder, and several of our listeners have written in with questions about that. And one of them actually mentioned melatonin. This seems to be a relatively common. It seems to have various degrees. You know, some people seem to have it pretty mildly, and other people are super active during REM. Could you talk a little bit about that? And do you have any advice or insights for the listeners that have REM sleep disorder with respect to melatonin or other things they should be doing?
I will defer on this one because I'm not a board certified sleep medicine specialist or anything like that. And for something like REM sleep behavior disorder, I think people need to find a local sleep center and see a medical doctor who's appropriately trained to get some more guidance. But certainly melatonin can be very helpful for those people. And REM sleep behavior disorder is something that can come on a bit later in life. So it might be that somebody's not experiencing its negative effects much at the moment, but they might develop into something more severe over time. So while I don't want to sound alarmist, it's definitely an instance in which you want to try and treat it as early as possible. I'll also add that sometimes people might conflate REM sleep behavior disorder with some other sleep problems. So there's a category of sleep disorders which relate to movement problems. They're sleep-related movement disorders. And these include things like restless leg syndrome, which is a condition in which people periodically kick during the night, and they often experience a kind of creepy, crawly feeling in their legs and sometimes other limbs too. And it's not nearly as problematic as REM sleep behavior disorder. So it could be that you're worried that you have REM sleep behavior disorder, but you actually have one of these other sleep-related movement disorders. And again, I would direct you towards a board-certified sleep medicine specialist. And if you go to a website such as the American Academy of Sleep Medicine, the AASM, you should be able to find one near you.
STEM Talk. STEM Talk. STEM Talk. STEM Talk. STEM Talk.
The science of circadian rhythm is a relatively new field that Greg has certainly embraced and made a name for himself for doing cutting-edge research in this area. In today's episode, we focused a lot on Greg's insights into the effects that a disrupted circadian rhythm and poor sleep can have on all of us. In part 2 of my interview with Greg dives deeper into ways to get a better night's sleep, as well as some of his other research interests, such as time-restricted eating, exercise, and nutrition. We wrap up part 2 of the interview with Greg talking about his new company, Resilient Nutrition, and the work he's doing to provide advice and supplements aimed at helping people feel and perform better. If you enjoyed this interview as much as I did, I hope you will visit the STEM Talk webpage where you can find the show notes for this and other episodes at stemtalk.us. This is Ken Ford saying goodbye until we meet again on STEM Talk.
Thank you for listening to STEM Talk. We want this podcast to be discovered by others, So please take a minute to go to iTunes to rate the podcast and perhaps even write a review. More information about this and other episodes can be found at our website, stemtalk.us. There, you can also find more information about the guests we interview.